The third lesson of this course is dedicated to the application, and we will see how to use optical data in a specific problem related to irrigated crops. And I will show you the methodology, and at the end an exercise will be proposed. So we will discuss on two topics. We will see two topics, the application and the discussion with the exercise. The application is related to water management in agriculture. The possibility to use data with very high spectral resolution, spatial resolution and temporal resolution make possible to analyze a large set of data, and in particular to analyze the phenological state of the vegetation and the crops. We will use two indexes, the vegetation index and the water index, and we will combine these two indexes to extract useful information. The application has been proposed as a study case in a conference in Florence this year. And as you can see, the application is the collaboration, this research is the collaboration between the University of Cagliari, University of Torino and Consorzio di Bonifica dell'Oristanese, that is an agency for the water management in agriculture. Which are the general objective of this analysis is to support the Consorzio di Bonifica dell'Oristanese for the control of water supply for irrigation and to verify the effective water usage as declared by farmers. Specific objective is to check the performance of optical data, and in particular to check the performance of this new optical data, the new Sentinel data, and at the end to propose a simple and very effective tool to verify the water content of each parcel and of each crops. The study area is an area in the western side of Sardinia, and in Sardinia in summer there is the problem of the water supply, so it's very important to monitoring the irrigation and to be sure that the farmers use in the right way the water. Here you see the land cover of this area, in red and purple the urbanized area or the artificial areas, in green the natural vegetation, and in red the cultivated areas. Which was the main requirements? The main requirements were to analyze each parcel as defined in the cadastral map and to monitor the change with a revisitation time of 7, 10 or 15 days, because it's very important for the technician to know what's happened in this temporal range. And on the basis of these requirements, Sentinel-2 optical data were selected as you know, it has a geometric resolution of 10 and 20 meters, a spectral resolution that is useful to analyze the near infrared and short infrared region, a temporal resolution of 5 days because 2 satellites are available, And the last is very important because the growing season for these crops is from April to September. So these are the months when irrigation is necessary. First requirements. Here you see in green there is the cadastral map that is overlaid on the image, and you can see that there is a very good geometric resolution, so we can recognize each field. The second requirement was the temporal resolution. 5 days is good time as a revisitation time, and so we downloaded a large set of data from March to November. Here you see the flowchart, the methodology. The methodology is very simple because you collect data, sentinel data. On this data you perform the atmospheric correction, so you can use the reflectance bands. This is very important because we have to compare the different indexes extracted for each bands, so it's very important, this step. Then you apply band calculation, an NDVI, and masking NDVI, you divide vegetation from bare soil. Then you apply the NDWI index, the normalized water index, to the vegetation areas and bare soil areas. And you can divide this to image, to set of image, and you can analyze the results for bare soil and for vegetated areas. The NDVI is the very known, well-known index, and here you see an area where in red is the vegetation, and in the image on the right you see that in bright white you see the vegetated areas, and in gray and in black the non-vegetated areas, bare soil and water. The water index is very similar to the other, but we use another band because we have other bands. We will use the band near infrared, so we will use the 8 band for Sentinel, and we will use the medium infrared band, that is the band 11. This band has a spatial resolution of 20 meters, so it's necessary to resampling this data before using it in the function. Here you see in the right image, in the bright color, the water bodies and the areas with a high value of water content, and in dark tones the area with no moisture. Software environment. We used for this application the tools, the semi-automatic plugin in the Quantum GIS. So we will perform all the data processing using this plugin, and as you will see, we will integrate the results in the GIS system with the vector data, the topographic maps. So the first step is to access to the system, and to choose the area the area of interest and the image of interest, and you can download the bands. For the band calculation, you can use the band calculation tool that is present in the plugin. This is very useful, very simple to use. You have only to write the function, and then you can extract the information. So, first step will be the application of the NDVI to the image, the masking. You divided vegetation from bare soil, and you will extract two different images. To each image you can apply the water index, and then you can reclassify using always the plugin. You can reclassify each bands to arrive to this information. So the first, the results are this that you can see in this slide. In this slide you see the vegetated areas in blue with a different content of water, the bare soil in red with a different content of water. So you see in the tones of blue and the tones of red the water content. This is for one area, and this is for this image. This slide is for another area, and each of this image is related to a specific acquisition time. So you can see how the water content change during the time, during the year. And this is a very interesting result, a very good result. So you can integrate this image in the GIS system, and then you can extract for each parcel the water content during the year. Here in this graph you see in blue the water content, and in green and in yellow the period where in this parcel there was vegetation in green or bare soil in red. So we will analyze the water content related, the increasing and decreasing of water content related to the vegetated and not vegetated surface during the summer. And you can understand if there are some the increasing of water content is related to the water, to the irrigation, because in summer there is no rain and the only water supply is irrigation. At the end of this methodology we can analyze the time series of the water index, and we can compare the increasing and decreasing of water content with the irrigation demand, because the owners have to apply for water irrigation as they pay the water. In this case we see that there is an increasing of water content in the field, and in this case there was no demand. So the technician can ask to the owner what happened, and in particular in this case he put water in the field without paying. So this is a very good methodology, and this image can be used to verify the water content values. The verification, the validation of the results was discussed, obviously, with the technician, and was verified with the existing irrigation demands. Moreover, some technicians from the agency went in the field and directly in the particles irrigated at the time of acquisition of the satellite data. The results obtained were extremely useful because the values of presence, absence of water were compatible with the field verification, and the anomalies that emerged in some fields have been attributed to possible water losses of pipelines, or were not associated with the irrigation demands, so was possible that the owners didn't apply for this water for irrigation. The geometric resolution of Sentinel-2 is very good and allows to discriminate the behavior of the individual plot, and the possibility to download and to access to continuous time series allows to provide an effective monitoring. From an operative point of view, it's very useful to use a simple and one environment to process image data and to integrate the results into GIS. And the idea is to propose an alert related to anomalous values increasing of water index in this application. Okay, at the end of this lecture, I propose this exercise, so you can try to apply the same methodology that we've seen before. Extract a time series of values of water content of a parcel on a cultivated area of interest in the image. Using the approach presented in this lecture, you have to download available image of your area of interest from the ESA website, and I propose you to download 3 images before the irrigation period and 3 ones during the irrigation period. So you have to know what is the irrigation period that you are analyzing. The second step will be to process the data according to the flowchart in slide 29. Then you will integrate the resulting image in the GIS using local topographic maps, and you will extract the information for one parcel, and you will build the graph, analyze the time series, and discuss the results through graphs and comments. Thank you.